AOPS number theory 6.21. Find the number of even 3-digit palindromes. So a palindrome is a number that is read the same forward and backward. So an even number is even if the last digit is even. So since it's a 3-digit palindrome, then we could write it as x, y, x. And since it has to be even, that means x is even, because x is the last digit, which means that both x's are even. So the first x is also even. So we know for even numbers, there's 2, 4, 6, 8, and 0. But if 0 is the first digit, that won't work. So it can't be 0. So it's just 2, 4, 6, and 8. So then for y can be anything from 0 to 9. So that's 10 choices. So there's 10 choices for x. 10 choices for y, and there's 4 choices over here. 4 choices for x. So in total, there is 10 times 4, which is 40 different 3-digit palindromes. AOPS number theory 6.22. Find the number of 5-digit palindromes. So any 5-digit palindrome can be written as x, y, z, y, x. And x has 9 choices. And they're the numbers from 1 to 9. And it can't be 0 because any number can't start with a 0. The first digit can't be a 0, so it must be from 1 to 9. Yeah, so it must be from 1 to 9. And y has 10 choices because it can include a 0, so it's from 0 to 9. And z also has 10 choices because it can include 0, and it's from 0 to 9. So the number of choices in total is 9 times 10 times 10, because there's only x, y, and z. So you have 9 choices for x, 10 choices for y, and 10 choices for z. And that's equal to 900. So there are 900 different 5-digit palindromes. AOPS number theory 6.23. Find the second smallest palindrome that is an abundant number. So if you looked at problem 6.5.4, we saw that 66 is the smallest abundant palindrome, and so then we would test 77 because it's the smallest palindrome above 66. So S77. So the factors of 77 is 1 plus 7 plus 11. And that's equal to, it's definitely smaller than 17, but I think it's equal to 19. So that's deficient because it's less than 77. So then we test the second smallest, the smallest palindrome above 77, which is 88. And the factors of 88, so if we just test the biggest from two smallest, so 44 plus 22 plus 11 plus 8 plus 4 plus 2 plus 1, we'll just do it all, which is 92. 92 is greater than 88, so it's abundant. And just label this as deficient. So the second smallest palindrome that is abundant is 88.